Okay, we are live. So today we're going to go over section 5E, which is about causality and correlation. But before we do that, I am going to, I'm going to go over a little bit of housekeeping for the class. So if you're watching this later on, if you're not in the Spring 21 QR class, you can just shut me off or kind of fast forward a little bit. But I've got to go over a little bit of housekeeping before we get rocking and rolling. So the housekeeping I want to go over is actually dates for the semester. So everyone that's turned in a full proposal, rough draft, I've gotten you back your rough drafts with edits. And remember that final paper is due April 30th by midnight. The majority of issues I saw in the paper really had to do more with APA formatting. And guys, I'm not going to be a ridiculous sticker for APA formatting. It's more about the grammar and the organization of APA. And of course, if you cite, it just use the APA format. The Al Purdue website, it's Al OWL. If you look up Al OWL APA Purdue, you'll see the website I'm talking about. It has a really good examples of APA. I would also, in the note I made in a lot of your edits was to go see Miss Althea in tutoring. Or if you're in the, support class, Miss Hodges will be a huge benefit when it comes to helping you write these papers. And really, the content was great. Overall, the content I got was superb. It really had to do with the paper writing aspect and the grammar, which they can help you out with tremendously. Okay, so don't lose points on that. That's in a way that's the easy stuff because someone can read it and help you with it. Okay, part of the journey of growing up, and I don't mean growing up, but the journey of learning is actually letting people help you, right? And having that initiative to ask for help. So let's look today. Today we are going to cover section 5E. It won't be a long section. It's on correlation and causation. And let me get to the book. There's not going to be a lot of math here. I'll probably draw a few graphs. But your book does a really good job of going over I believe it was correlation first. Let me get started. 5E starts on page 342, and it's titled properly Causation or Correlation and Causality. And first, your book defines correlation. So correlation exists between two variables when higher values of one variable consistently go with higher values of another variable, or when higher values of one variable consistently go with lower values of another. Okay. What this means is, and they give examples. So if the first example is like weight and height, right? On average, I don't know where my head is to the side. On average, if you are taller, you weigh more, right? That's not always. It does. Then that's not really what this is about. It's not about single anecdotal evidence of this. It's about a larger amount of evidence. So if we kind of ran with that example, and they're going to go into graphs here in a minute, but I'm going to draw this little graph. Let's see. We'll put the x-axis as let's say weight, and the y-axis is height. So let me flip this over to my desktop camera just to kind of show you the graph aspect of what's going on. So if we've got, let's say we go survey 10, 12, 13, 14, 15, whatever amount of people, and all we wanted is their weight and their height, okay? What we'll notice, now I'm not going to put any digits here, but what we'll notice is we'll see this positive correlation, okay? A shorter person will probably weigh a little less, right? And then as it goes on, someone that weighs a little more is going to be a little taller and so on. It'll look something like this, okay? And this graph has a nice positive correlation. Now, you might have a few people that are really tall that don't weigh that much, right? Real lanky guys, right? Or gals. So really tall, but just don't weigh that much. Or you might have someone that's really short that does weigh a lot. Okay, that's me. Okay, so you can have these people out here, but what we're looking for is a trend overall. Okay. And what you see is that when you ask people about their heights and weights, or you take people's heights and weights, it does line up with a nice positive correlation, nice positive correlation. Okay. I mean, other correlation your book goes over is like the demand for apples and the price of apples. When the demand tends to decrease, the price tends to increase as well. Negative, there's a correlation between practice time and skill, right? The more you practice, the greater your skill becomes. And of course, you can have negative correlation. This is an example of positive correlation, right? As one increases, the other increases. Negative correlation would be, actually, if you looked at temperature and crime rates, I think we kind of talked about this before. Temperature and crime rates has a negative correlation, okay? So if we looked at, this was temperature, and this was crime rate for a certain city, you'll see as the temperature goes down, the crime rate also goes down. Okay, the crime rate also goes down. So this is a nice negative correlation, right? When one goes down, actually, you know what? Oh my gosh, I got this backwards. Because if temp goes up, crime goes up. This is let's just strike that from the record book. Okay, let's think of actually something that might go down. Okay, yeah, this will make more sense. That was a horrible example. Let's just act like that didn't happen. If we looked at temperature and coat sales, temperature and coat sales, right? So the number of coats sold at a certain, TJ Maxx, wherever. As temperature goes up, the sale of coats will definitely go down. Okay. So therefore, this has a nice negative correlation, right? As temperature goes up, the sale of coats would go down. Now, you might have some weird time or weird month where you actually, maybe put all the sales, maybe in a warmer month, you put all the coats on sale, like really cheap. So maybe one pops up, or vice versa. The temperature is really low, but then you don't sell that many because maybe everybody has a coat, right? That those things might happen, but overall, it's going to follow a nice trend line. Okay. So this would be nice negative correlation. The last, I'm probably getting ahead of myself, guys, because I think, I'm getting a little bit ahead of myself. But so the idea, though, is to think of the two things that correlate together, that happen together, either positive or negatively, right? And then you have this nice correlation between them. The book, what else does your book go? I mean, you might think of like exercise and weight loss, or your weight. That would have a nice negative correlation, right? The more you exercise, the lower your weight goes. So that would be a good example of a negative correlation. Okay, let's go to the next slide. The next part goes actually over the scatter plot, which I kind of mentioned. And it says a scatter plot is a graph in which each point represents the values of two variables, right? So if each point on those last two scatter plots represents either the temperature and the crime rate, or the coat sales and temperature. Okay. And then the book goes over different types of correlation, and really there's three different types of correlation. This is on page 345. The positive correlation, which we talked about, is both variables are going to increase together, right? The negative correlation is where one increases, the other decreases, and then there's no correlation. Things that have zero correlation together. Okay. And then the book says there's no apparent relationship between the two variables. So sometimes it's weird. It's kind of hard to think of things that just have zero correlation. If we go back to that temperature example, something that is not correlated with temperature would be something that's just not correlated with temperature. I'll tell you, I'm going to make one up. Okay, I'm going to assume that things that aren't correlated with temperature would be, what do you think? Can you guys think of something that wouldn't be correlated with temperature? Something that would not be correlated with temperature. Put it in chat, that's fine. Think it's something that wouldn't be correlated with temperature. Let's just say amount of money in my checking account. There would be no correlation with temperature and the amount of money in my checking account. I don't make more money in a certain, when the weather's a certain way, I don't make less. We get paid throughout the entire year, so it's not a big deal. So if you think of this as money in my bank account, okay? Money in my bank account and temperature, it would be all over the place. It would look like a shotgun, okay? You check, actually, it would be a lot more down here than up here, but it would just be all over the place. This would be no correlation, okay? So if we can't draw like a nice trend line through it, it just means these things are not correlated. So the amount in my checking account and temperature, just no real correlation. Okay, it might be correlated like if for somebody else, maybe if it was somebody that made money off of, let's say like someone that mowed yards for a living, right? You might see a trend here where as the temperature increases, you would see more money in their checking account, right? But for me, it's not, because I don't get paid that way. I don't pay for something more or less because of the temperature outside. Okay, and then the last thing your book talks about in that section on 345 is strength of correlation. So the strength of correlation is the more closely two variables follow the general trend, the stronger the correlation, which may either be positive or negative, right? In a perfect correlation, all data points lie on a trend line. And you're just not going to see that in nature. In nature, you won't see a nice, perfect trend line. Now, you might see it in, if you looked at like money in your savings account, or not really savings account, but if you put money like under your mattress each month, that would be a nice perfect correlation, right? If you put the same amount in your mattress each month. So if you put $10 in your mattress each month or under your mattress each month, then that would follow a perfect trend line, right? Because each month it's increasing by 10. That's the only way. I mean, there's probably other examples like that, but when it comes to nature and surveying people or events that occur, you're just not going to see a perfect trend line happening. Okay. If it is, it's a manufactured trend line. Oh yeah, your book is a really interesting example. Example 2 on the Podring page 346 talks about the accuracy of weather forecasts. And it turns out the accuracy, it plots the actual temperature on the Y and the forecasted temperature on the X. And it's pretty dang close for the 3-day forecast, right? Or same-day forecast, I'm sorry. The same-day forecast has a much stronger correlation than the 3-day forecast, right? And then I'm assuming if you go out to 10-day forecast, you'd have the same issue where it gets weaker and weaker and weaker, right? The strength of the correlation gets weaker as you increase the amount of days you're trying to predict, right? Makes sense. It's harder to predict 10 days out than it is to predict the exact day. Okay, and then on page 348, it goes over possible explanations for a correlation. The first one is the correlation may be just a coincidence, right? It might, there are crazy coincidental correlations. I bet if I Google coincidental or coincidental correlations, coincidental correlations, I bet I can find some. Examples. So let me do examples. Yes. Okay, cool. So here, oh, that's fun. So here's a good example of coincidental correlation. That it's from Science News for Students. Let me share my screen here. And it says the divorce rate in Maine and the per capita consumption of margarine. And it turns out the divorce rate in Maine, which is down here, so we've got time down here. This is a little different than what we were talking about because this is a trend line and not a scatter plot. But we've got the trend line down here, the years, and we've got the divorce rate, which is in this red. So it's decreasing as time goes on. And so is the per capita consumption of margarine. Of course, these things don't matter, right? These things are coincidentally correlated. Let's see They have any other examples here? No, it's just this one. Okay. But this is definitely just a coincidence that the divorce rate in Maine decreases along with the per capita consumption of margarine over time. So one, we could just have a pure coincidence in it happening. Two, both variables might be directly influenced by some common underlying issue, right? I mean, if we looked at the probability of you using or probability of you of oh gosh, something it's about to rain today. We can think of a good one with that. The probability of my windshield wipers being used and the occurrences of my windshield wipers being used is really tightly correlated with the occurrences of me bringing an umbrella, right? I mean, it makes sense. If I'm using my windshield wipers, probably going to bring an umbrella. Of course, I'm going to forget to bring the umbrella, but the probability that the windshield wipers are being used also strongly correlates to the probability of me using or me bringing my umbrella. Well, of course, those things correlate together, but they're influenced by a very major underlying issue, which is the rain, right? Each of those actually has everything to do with the rain. As the probability of rain increases, I'm going to use my umbrella, right? I'm going to bring my umbrella. Or the probability that rain increases, I'm going to use my windshield wipers. So that's what it's talking about, a common underlying issue where those two might correlate well together. They're really going to correlate well together, right? Bringing an umbrella and using my windshield wipers, right? Definitely going to correlate high together. But actually, the underlying issue has to do with the rain. Another one that is very common that we see as educational statisticians is really, if you look at overall student success, there's a very common misconception, extremely common misconception, because there's a correlation between or what's used is a correlation between like race and success at universities. So let's say, oh well, the minority student has a lower chance of success at the 2-year school or the 4-year school, and we hear this a lot. Well, I can tell you, I can promise you, the probability that you succeed or don't succeed has nothing to do with the color of your skin. Okay, if you pop out green or whatever color, okay, of your mother's womb, it will not correlate to just because you're a certain color does not mean that you'll understand algebra better or that you'll have a higher chance of getting done with a university. It has nothing to do with that. What really the underlying factors actually is strongly correlated with income of your parents. And so what happens though, both of those have a correlation, right? Income correlates with your minority status, right? On average, minority students come from lower income households, okay? And then if you look at student success, there's a higher success for students that come from higher income households. So the underlying issue is income, right? Now, there's a lot of other issues. It's not that because your parents are poor or your parents are rich is why you succeed, but there is a trend in that. Okay, it's kind of like the weight thing, right? You're still gonna have short, overweight people and tall, skinny people, and there's a lot of those people out there. There's a lot of people that succeed for whatever color of skin they are or whatever income their parents are. But there's also a trend line that comes to that as well, and it's true with the ACT. It's true with high school graduation rates. It's true with college success rates. It has to do. It doesn't have to do with the color of your skin. That's ridiculous. It has to do with your income levels. Now, why you're at that income level, that's a different study, right? Why a family is at that income level is different. I'm not going to go there per se. There's a lot of historical factors and things of that nature involved in that. But to say that someone's not going to succeed because of whatever skin shade they are is ridiculous. And so when you hear that argument or you hear very bigoted people bring up that argument, you just in one ear make it go out the other. Okay, that's ridiculous. It has nothing to do with skin tone. It has everything to do with opportunity. Okay, Now, look, I'm not saying you can't. Gosh, I'm going to bring this back. I'm not saying that, just because you're the skin tone, you have a higher chance of failure or things like that. That's not what I'm talking about. It's more about the trend line of that happening. Okay. Okay. So back to this. Let me get on my soapbox just a minute. So the last thing everybody talks about is one of the correlated variables may actually be a cause of the other, right? Note that even in this case, it may be only one of several causes, right? The reason you succeed in college, for example, has many causes, right? We've seen a lot of we've uncovered a lot of neat things in research on community college and four-year college success that have nothing to do with income. Now, income is one, right? But also like parents' level of education, which kind of correlates with income as well. But parents' level of education is one as well. The family structure is one. If your family is one that values education, right, you're going to have a better structure. If someone in your family's gone to college, you have a better chance because you kind of have insider information, right? So all of those things have a correlation to your success as well. That doesn't mean you can't succeed and not have any of those, right? But it's almost like things that kind of help. You're kind of like privileges, right? I mean, if I had a family member that worked, like my kids are really have a really neat kind of privilege that I work on a two-year campus. I work in higher ed. It will be a little bit easier. I will know some barriers that they're going to have to face that I can help them with, or maybe that they just know about that a typical two-year student wouldn't know about, right? And it's not that it's nobody's fault. It's just they luckily happen to have a dad who works at a two-year school. Okay, so there can be a lot of things that correlate, not just one single variable that kind of props up the other one, right? Now, some are direct correlations. I mean, the probability of me bringing an umbrella to work is directly correlated with the probability of it raining that day, right? That's a direct correlation. I don't do the sun umbrella thing, so that's a direct correlation. But other things in nature just have a lot of different correlations that are involved. Oh, another one with student success has a lot to do with your school being funded, which has nothing to do with you or your background, right? If your school is properly funded, your university is properly funded, you have a much higher chance of success because your university can fund things like advising centers, student activities, engagement activities, co-curricular activities. So that has nothing to do with the student, right? I mean, that's not a student background issue. That's a state funding issue. So that's another example of how you could have just these correlations where these things, there are correlations and causations, but there might be a lot of reasons why. And typically, there are a lot of reasons why students succeed or don't succeed for that example. Okay, definitely got off in the weeds a little bit. But your book then goes over 6 steps or guidelines for establishing causality. The first one is look for situations in which the effect and correlated. Oh, actually, let's talk a minute about causality and correlation. I don't think I've directly mentioned it, right? Maybe I have, yeah. So correlation means that these two things can just happen, right? They happen, they correlate. Causation, when you hear the word causation, though, it means that one directly causes the other, right? Now, again, there might be multiple reasons for causation, but a variable causes another variable to occur, okay? So one variable depends on these other causes. So you'll hear dependent and independent variable. I'm not going to go into that, but just realize there might be multiple causes, but one of those variables causes the other, or multiple variables causes the other, right? So there's a guideline, though. Your book establishes a guideline on to find causality and not just correlation, right? First is look for situations in which the effect is correlated with the suspected cause, even while other factors might vary, right? Even though other factors might vary. 2, among groups that differ only in the presence or absence of the suspected cause, check that the effect is similarly present or absent. Look for evidence that larger amounts of the suspected cause produce larger amounts of the effect. If the effect might be produced by other potential causes, make sure that the effect still remains after accounting for those potential causes. If possible, test the suspected cause with an experiment. If the experiment cannot be performed with humans or for ethical reasons, consider doing an experiment with cell animals. Well, what if it affects the animal? Anyway, cell cultures or computer models. And 6, try to determine the physical mechanisms by which the suspected cause produces the effect. Okay, this is how we try to decide if it's a causation or a correlation, right? If it's a causation or correlation. Your book goes over a really interesting case study with airbags in children. You're more than welcome to read it. Also with cell phones and driving. And then the last thing your book talks about is broad levels of confidence and causality. So you've got possible, probable, and cause beyond reasonable doubt. So possible cause, we've discovered a correlation, right? We know there's this correlation between cigarettes and people dying young, right? Man, these people that are smoking, they're not living as long, right? We notice that. That seems intriguing. But cannot yet determine whether the correlation implies causality. In the legal system, possible cause, such as thinking that a particular suspect possibly caused a particular crime, is often the reason for starting an investigation. So maybe, this hospital in Baxter County sees that, man, whenever we have people come in that have been long-term smokers, and this is old stuff, right? But long-term smokers, they're really dying at a younger age than people that don't. Maybe we should dig into this more, right? And the next is probable cause. We have good reason to suspect that the correlation involves cause, perhaps because some of the guidelines for establishing causality are satisfied. In the legal system, probable cause is the general standard for getting a judge to grant a warrant for a search or a wiretap. So now we're like, say you're a doctor, right? Or a nurse or, a tech. And you're like, I notice these things. I'd really like to study this. This seems interesting. And so you notice this trend. People coming in, they're smoking, they're dying young. You're like, okay, I've definitely established some sort of possible cause here. And then you're like, okay, I'm going to go to my boss and see if I can get a grant to research this. So you go to your boss. Your boss is like the judge in this scenario, right? And you're like, hey, I want to show you this data that I've taken on my own. And I've noticed that out of these 50, patients that have come in, 30 were smokers and they passed away at this age, and 20 weren't smokers and they wound up living, past this age, whatever. So, and then the boss or the grant, program says, you know what? I think this is worth investigating. Something seems fishy about this. There might be a causality. Go ahead, go research this work and see if there is some causation here, right? So lastly, we've got cause beyond the reasonable doubt. It says we found a physical model that is so successful in explaining how one thing causes another that it seems unreasonable to doubt the causality. In the legal system, cause beyond reasonable doubt is the usual standard for conviction. It generally demands that the prosecution show how and why the suspect committed the crime. Note that beyond reasonable doubt does not mean beyond all doubt. Okay, that's two different things. So for our cigarette example, what we've done is we've created a model now. We said, you know what? If you smoke, let's say if you start smoking at the age of 18, we have created a model on the confidence that we can say how long you will live, right? And then what happens is, even though some people, we know people that have smoked their entire life that wind up living to 90, right? But then we also know people that smoke their entire life and they die of lung cancer at 57. So it's looking at the model and seeing if the data that's actually happening at that hospital fits the model. And then the data that's actually happening at all the hospitals across the US or the world is fitting that model, right? And then you've got beyond reasonable doubt, right? I mean, it's not perfect because, again, especially with human trials, it's not perfect because you've got some humans that will survive a lot longer, and then some that pass away shorter because of lung cancer for whatever genetic reason. But that's a good example of how those three kind of correlate. Nice pun intended. But those three reasons on page 351 correlate. Okay, so for homework today, the homework in 5E, let me go into your class show and make sure this is correct. 5E, the homework is 1 through 47 odd. I would do 1 through 41 odd. You can do 1 through 41 odd. I'll tell you on this test, I'm probably going to have a few open verbiage questions where explain two variables in the real world that correlate together, or explain correlation or causation using two variables. And I want you to make up those variables. I really want you to think about it. Okay, think of two variables that could happen. I can think of a sport one right off the top of my head. If you enjoy watching football, the rank of your offensive line correlates with the number of wins for your team. That's a correlation, right? If you have a really good offensive line in the NFL, you actually have a higher chance of winning more games in the season, right? Something like that. So anyway, if you guys have any questions, let me know. That's it for 5B. It's not a long section, and I will see everyone in the next class lecture.